Okay, we can also integrate rational functions ratio of polynomials by expressing them as sums of simpler fractions called partial fractions. So that we already know how to integrate. And so this example is going to show us this case. Okay, so we need to make sure we review partial fractions. Right? So let's take a look here. So we notice that this denominator, okay, so let's go ahead and take a look at this. The denominator can be factored. So we know that we got 5x minus 4 all over 2x squared plus x minus 1. And that's the same thing as 5x minus 4. And when you factor, you end up with x plus 1 times 2x minus 1. Okay? And so then what we can do is then we can say that this becomes a over x plus 1 plus b over 2x minus 1. Okay, so what does that ultimately give us? Well, what we know is the following. We know that we have 5x minus 4, which is going to equal a times 2x minus 1 plus b times x plus 1. And so now we need to make sure that the coefficients of x and the coefficients of the constant are the following. So what we can do is we have 5x minus 4. If we distribute the a, we have a 2x minus a plus bx plus b. So again, going back through our partial fractions definitions, we can see that we have these two formulas. We have a, or in this case, 2a plus b, and that's going to equal 5. And then we have the constant, negative a plus b, which is going to equal negative 4. Now, if we solve this system, so from here what we want to do is we want to be able to solve this system here. So we have 2a plus b equals 5. We have negative a plus b equals negative 4. Okay, multiply this by negative 1 and then keep this one the same. So we have 2a plus b equals 5. And then we end up getting positive a minus b equals 4. So we have 3a, which is equal to 9. So a is equal to 3. And then back substitution, we would see that b is then equal to negative 1. Okay, so now again, using the definitions of partial fractions, we now know that if we want to integrate 5x minus 4 all over 2x squared plus x minus 1 dx, we now know that that becomes the following. So we have 3 over x plus 1 minus 1 over 2x dx. Okay, so now let's use the substitution. So if we split these up, we would have 3 over x plus 1 minus 1 over 2x minus 1, and separately integrate that. So for this first one, we're going to let u equal x plus 1. And then the second integral, we're going to let u equal 2x minus 1. And so therefore, we would end up with 3 times 1 over x plus 1 dx minus 1 over 2x minus 1 dx And so here we know that du is going to equal 2 dx, and therefore dx is going to equal 1/2 du. And over here, du is going to equal dx. So that's going to allow us to get the following. So we're going to have 3 times 1 over u du minus, factor out the 1/2, 1 over u du. And then we would get the following. 3 times the natural log of the absolute value of u minus 1/2 times the natural log of the absolute value of u plus c. And then using the substitution, we have 3 times the natural log of the absolute value of x plus 1 minus 1/2 times the natural log of the absolute value of 2x minus 1 plus c.